Hi guys, today we're going to learn about solving absolute value equations and inequalities using the TI and Inspire. So the first thing that you need to do obviously is to read the problem. Here you have the absolute value of 3x plus 1 is equal to 7x. So to plug it here in your beautiful calculator, what we're going to do here is you're going to set your left side equal to f of 1 is equal to absolute value of 3x plus 1. Then the second equation that we're going to put in our calculators is going to be f of 2, which is going to be the 7x. As you know, this equation that we have over here, it's an equality. Therefore, what we're going to look for is the intersection of these two equations. So let's start with the calculator. Okay, so I have here my calculator. Okay, so what I'm going to do here is I turn my calculator on, and you can see that I already have stuff there. So you go to documents, okay, you go to file, you want a new document, you don't want to save, okay, so let's start from scratch. You add graphs, and then you plug your equation. How can you plug the absolute value equation? What I do, I plug I type A, B, S, and then I put a parenthesis here, and I put whatever is in the absolute value inside of that. So you have that it's 3 x plus 1. Okay, so that's your first equation. You can see the first equation over there. Then I plug my second equation. How can you get another graph here? Well, what I do, I press this one tab, okay, over here. As you can see, now the cursor is blinking there. So you have that, you type your 7x and you hit enter, okay, so you have the second graph here. So your right graph is going to be the red one. So you see that they are intersecting there, okay? So if you want to see it more clearly, what I do is I go to menu, okay? I go to zoom, window zoom, select that one, and then I go to zoom fit, okay? Zoom fit, it will take you exactly to where interesting things happen to the graph. So over here you have the intersection. So what I'm going to do, I do menu, and then I do graph, analyze graph, and then I go to the intersection because that's what we were looking for. You're going to see this dotted line. So what I do is I basically drag it like further from the intersection. Okay, I select this and then I drag it further to the right to the intersection. Over here you can see that your intersection is at point 0.5, 1.75. So what you care here is the x. Therefore, you have the solution. So I'm going to write my solution here in set notation. You know that your solution here is 0.25. Please remember to use the squiggly lines here. Another way that you could write it that it's correct is a squiggly line 1/4, because you know that 1/4 is the same as 0.25. Either or would be completely correct. Okay, so let's look at problem number 2. Okay, so problem number 2, you have a similar situation, but what's the difference? Here you have an inequality instead of an equation. So we're going to deal with that after plugging in the calculator, okay? So the first thing that you can recognize is that f of 1 of x is going to be equal to the absolute value of 4x minus 15. And then the second equation that you have, that it's f of 2x, is going to be equal to the absolute value of x. Now that we have this, what I'm going to do is, again, use my calculator, okay? So here, I'm going to go to doc, okay? File, new. You don't want to save because you want to start from scratch. Add graphs. In adding graphs, you know that this one is going to be the absolute value. And in this situation, you have inside the absolute value for x, and it was minus 15, okay? So you graph that, okay, which is the left graph, the left equation that you have, sorry. And then you press tab again, and then here you're going to type the right graph. In this case, you have that it's the absolute value of just the x, so ABS, and just the x is inside the absolute value, so that's going to be your second equation. Now, here what's the deal? The deal is that you see your equation. Let me move it so you can see the equation here. So you want that this guy, okay, that according to this graph is the blue one, be above the red one, okay, when that happens. So you know that from negative infinity to looking at the x's, negative infinity to this point, you have that blue is above red. You see it? Then from this point to the other intersection that it's here, you see that red is above blue. Okay, so and then from this intersection to positive infinity, you see that blue is above red. Okay, so we need the intersections here to conclude. Okay, but you see that this one is the one that needs to be above. Okay, so I go to menu, I find my intersections, right? Analyze graph, and then intersection, you have this dotted line, so I'm going to select here, and I'm crossing here the first intersection. Okay, so you can see that that one is 3, 3. Okay, then I do the same, analyze graph. Okay, when you analyze graph, if my calculator reacts. Okay, so you look for the intersection, then you select that, and you scroll up till you get the second one. Okay, so you see that your intersections, and you just look at the x, is going to be the 0.33 and the 0.55. For x and what we care, it's the 3 and the 5, the ones that you care. Okay, so here, okay, I know that my graph, that it's a red one, when it's above, is from negative infinity, okay, to the 0.3. Let me move it so I can write. Okay, union, and in this case we have that it's 5 to infinity. This is in interval notation. So for problem number 3, we have something similar to problem number 2. What you have here is that you realize that you have the absolute value of 2x minus 9 is less than the absolute value of x minus 6. So the one that you want above, it's going to be this one. Okay, this one you want it above. Okay, the first thing obviously that we're going to do again is I'm going to put in my calculator f of 1 is going to be the absolute value of 2x minus 9, and the f of 2 is going to be equal to the absolute value of x minus 6. Okay, so let's plug that in the calculator and see what happens. So when I go to my calculator, I go to graphs, file, okay, new document. You don't want to save. Okay, you add your graphs, and what I'm going to do, I type ABS parentheses. Okay, we have that, and then I plug 2x, and it's minus 9 in this situation. Click that, you have the situation. Now you are going to press tab. Okay, you plug the second equation, which is going to be ABS parentheses x minus 6. Okay, so you have this. Clearly you can see that you have intersections here and here, so let's search for them. I go to menu, analyze graph, then you go to the intersection here. Okay, meaning that I go from here to here. Okay, and then I repeat the same process, analyze graph, intersection. Okay, and if my calculator reacts, okay, so I select something around that intersection. So you can see that here the part that I care, remember, is only the x, so I care about the 3 and the 5. Okay, now furthermore, you can see that since I want the red to be above, you know that the red is below from negative infinity to this point, which is 3. Okay, so the part that we care in this situation is the middle, because it's when red is above blue. Here it's clear that it's below, so the only part that we care is this middle interval. Do you see it? Okay, so hopefully you do. Okay, so I'm going to write it again in interval notation. You know that it's going to be from 3 to 5, and you can see that I'm not including them because it's not an equal there. So if I want to write this in set notation, I would write it as follows: x such that, and you have that it's going to be x that it's in between 3 and 5, so this would be your set notation. Okay, now I'm going to skip 4, and I'm going to, because 4 is very similar to this one, okay, just with the equal. So for this one, basically you just need to use the bracket. Okay, so I'm going to move on to number 5. So number 5, you already have the graphs here, as you can see them. You have a screenshot of the situation. So here what you have is that you have this side above this one. Which one is this side? This side is red. So do you care about this part? And please always assume that the calculator, these are arrows, okay, when you're seeing the calculator like that. So you care when red is above. Here blue is above from negative infinity to the point negative 1.875. So what's the part that we care? We care about this part that you see here. This one we don't, because blue is above. And what do you want? Red okay, that it's above. Okay, so for this one, what you have is that your solution interval is going to be bracket. Why bracket? Because you have the equal. Okay, so it's going to be negative 1.875 comma 1.5 because it's your second intersection over here. Okay, if you want this in set notation, how can you write it? You write it as x such that negative 1.875 is less or equal than x less or equal than 1.5, and close it with the squiggly line. And that's pretty much it. Hopefully you find this video helpful. Bye!